3D printing is basically taking a digital model that you have on your computer and building it out of a printer into thin layers.
So this is just a simple little calibration test that came with the printer. Nothing too crazy. It's just a cube with some holes, or a lattice. So one of the nice things about the software that came with this printer is that you can actually see what it is going to look like as it prints, layer by layer. You can do like a high quality, low quality, or medium quality, which is basically how much cross-hatching goes in here. So what I did now already is I preheated the bed and I preheated the extruder, and the extruder is the nozzle that actually puts out the filament. And so one of the things that you also want to do is make sure that you have adhesion on the actual printer bed. So you can use glue or just a glue stick or some hairspray or vinyl or something. So you put it in the space that it's going to be printed so you don't get any warping. So right now what's going on is first it's putting a dot down just to calibrate itself. So the bed is at 50 degrees and then the extruder itself is at 200, and it's supposed to be about 210, and the extruder temperature is dependent on the material that you're printing with.
So one of the big issues with 3D printing right now is that pretty much everything has to be going like perfect for it to work. So your printer bed has to be completely level, the bed has to be heated, the material has to, well, the bed doesn't technically have to be heated, but it helps it stick to the printer bed. And that in and of itself is its own problem, because if it doesn't, then you get warped prints, which completely ruin everything. If you were to have like some sort of different stresses that were pulling it in the way that it was layered, it's obviously going to be a lot weaker, and so that puts a lot of limitations on what you can do with it, which goes back to the prototyping, which is why as of now this is only feasible for doing prototyping, because it can't handle forces from every which direction. So I'm actually part of a club right now that's working on prosthetics. We had printed a hand for somebody who had lost part of their right arm. Right now we're working on animal prosthetics right now, so that's something that's really exciting. But every day you're seeing how there's more and more trash popping up in the oceans, and birds are eating it and the animals are eating it and stuff. They've developed these things called fillustrutors, which grind up all of the used filament. So pretty much anything that's scraps or that you don't want, you can just throw it in a blender. There are some things like with this Stormtrooper, it couldn't just print it straight up like this. It had to print some support material. So when you break that off, there's nothing else really to do with it. And so the great thing about a fillustrator is that it grinds it up and then it respins it back into a spool just like this, and then you can reuse it. And so what a lot of people are trying to do nowadays is try and find a way to use the plastics that we have now on water bottles and gallons of milk and stuff, and recycle that and reuse it, because if you do that, you're never going to have to make plastic again. There's a lot of applications for the medical field, for aerospace industries, for plastics industries, recycling. It could completely change the way that the whole world operates. I'd say the future is pretty bright.